All right, so law of cosines theoretically is easier than law of sines, but the math can be cumbersome. I'm not usually one for memorizing, although you have had to memorize certain things. And you really don't have to memorize your law of cosines formulas because they make a lot of sense as to how they're made up. And in addition to that, if they change the side lengths and the angle names from A, B, and C, then what do? How do you deal with that? So you kind of have to look at the pattern that they've given you. I personally, if you're talking, you're not listening. I personally would just memorize that. Because if you know that, you can derive all the other formulas. If you know that one, these ones are all used if you're finding a side length. These ones over here are used if you're finding an angle measure. This one tends to be easier to learn than this one. This is derived algebraically from this one. So instead of learning two different formulas for the same thing, I just learned that one. And look at how it works. We have three different sides, A, B, and C, or X, Y, Z, or P, Q, R. Whatever the sides happen to be, we have three different sides. One of the sides is going to be over here on the left squared. That's the side that you're typically looking for. Or if you're looking for a particular angle, the side opposite that angle is going to be the one over here. So if I'm looking for angle A or side A, I'm going to put A squared by itself over here. Then the pattern goes, it looks very much like Pythagorean's theorem, doesn't it? And really the law of cosines is an adjustment to Pythagorean's theorem. And again, if you want the proof for that within Appendix A of your textbook, or it's on the Khan Academy, be my guess. But I take the other two sides, I square them and add them together. Every single one of these looks like that, right? So if I have B squared over here, the other two sides are A and C. They're being squared and added together. C squared is over here, the other two sides, A and B, are being squared and added together. Then you always have minus 2. And in these two sides, they're on the same side that were squared, are just being multiplied singly together. And then you take the cosine of whatever is by itself over here. They're all the same. This one, you're going to have a lot more room for error. I'm just saying if you try to memorize that one. So I wouldn't. So I won't teach it that way. So I'm only going to teach it from here. So I'll use one of these. But once you know this, you should know how to come up with these. Law of cosines is only used for SSS, meaning we have all sides and no angles, or SAS, meaning we have two sides and the included angle. That means that I do not have the side across from the angle that I was given. Because if I have the side across from the angle that I was given, I'm going to use law of sines. The math is easier. All right, so we're going to solve a triangle. So again, it doesn't matter what your triangle looks like, whether you have acute or obtuse angles, don't worry about that. Just draw a triangle so that you can put in the things that they have given you to see if what you have to do. Because you're going to have to decide probably today, should I use law of cosines or law of sines? So you're going to probably mix both of them up on you. I've been given A, and if I were you, I would actually write A equals 13, because when you put these into the formulas, you're going to forget which one is which and put them in the wrong place. So if you identify it, you won't have to worry about it. Across from angle B is side B equals 18, and across from angle C, C equals 26. Because I do not have an angle across from any of the sides, and I have no ability to find these angles without the law of cosines or law of sines, then I'm definitely using law of cosines. So that's the first thing. So I know I'm using law of cosines. That's the first determination that I have to make. On your test, I'm not going to tell you, use law of sines here and use law of cosines there. I always try to evaluate it for law of sines, because that's the one I prefer to use. So then the other thing I would like you to write down, which would be handy to know, is typically with law of cosines, start with the largest side. So start with the largest side and work to your smallest side. You're less likely to make an error that way. So my largest side is 26, and it is across from angle C. So that means I'm going to find angle C first. So step 1. I'm finding angle C, so I'm going to put C squared by itself on one side. The other two sides, A and B, get squared and added together. Then minus 2 times these two sides multiplied together. And then the cosine of the side that's on the other side by itself. Now you're going to plug in what you know. All I know are the side lengths. And we're going to use our algebra to get the cosine of C by itself. So C is 26, and A is 13, and B is 18. So then 13 and 18 here. And perform your math. 26 squared is 676 equals 13 squared is 169 plus 18 squared is 324 minus 2 times 13 times 18, 468 times the cosine of C. Well, we are trying to get our trig function by itself. Can I do 169 plus 324 minus 468? No. Why? It's being multiplied by this one. So I can only add those two together first. So those added together are 493. So I'm going to subtract 493 from this side and 493 from this side. So those cancel. And I'm left with 183 equals negative 468 times the cosine of C. Still trying to get the trig function by itself, so what do you do now? Divide by negative 468, divide by negative 468. So those cancel. So I have the cosine of C is equal to negative 183 over 468. How do I find C? You have to do the inverse, right? So what I'm not seeing from some of you is your notation. So the measure of angle C is going to be equal to the inverse cosine, and this is what you're going to plug in your calculator, of negative 183 divided by 468. And that's going to be an approximation. And here we go. Again, make sure that calculator is in degrees. So inverse cosine of negative 183 divided by 468. Say that? Yeah. Take, what do you mean square it? That's a squiggly equals.
Oh,
sorry. Yes.
How close are you going to be?
It should tell you round to the nearest tenth or hundredth. Since none of our side lengths are in tenths, I would go out to tenths. I mean, I don't want to go to the nearest unit, just because these are to the nearest unit. Typically, I won't round to a whole number. So I would say here you're good to go to the nearest tenth. But if the directions specifically say the hundredth or the tenth, you have to round to that. So just pay attention to it. So we're going to go 113 point, and I'm going to actually put 0.0 because I'm going to go to the nearest tenth. If I had just put 113 degrees without putting the 0.0, that would imply that it actually came out to be exactly 113 degrees, and that isn't so. So make sure that you put that 0.0 in there, and then I'm going to throw that in my picture where it belongs. Then what's my next biggest side? B. One of the reasons why I suggest that you start with your largest side is when you do the law of sines, you really don't want to be doing the law of sines with an obtuse angle because it could create some difficulties for you. So avoid that at all costs. And so now I'm going to look at B, and I'm going to work with B first. So then step 2, we could at this point move to the law of sines, because I now have an angle across from here. I'm going to show you my work for the law of cosines, and show you that we could come out with a different answer. Sometimes we come out with the same answer, sometimes we come out with a slightly different answer. So we'll see what happens with this one. But I'm going to use the law of sines, only because the math is easier. I have these two. I'm finding an angle. So because I'm finding an angle, I'm going to put the sine of the angle up top. So sine of 113 degrees over side C, which is 26, equals sine of angle B over side B, which is 18. I'm solving for sine of B, because I want to get that by itself. So I'm going to multiply both sides by 18, or you can cross multiply, it just creates an extra step. Bless you. So instead of writing sine B equals, I know that I want to solve for angle B. So can't I just do the inverse sine of all of this? Right? And that's what I'm going to throw on my calculator. 18 times the sine of 113, and that's 0.0, which doesn't really matter in this case, degrees, divided by 26. You have to be careful in your calculator that you close the parentheses for that 130 or 113 degrees. Otherwise, it's not going to calculate it correctly. So inverse sine, 18 times sine of 113 degrees. So make sure you close that parentheses, divided by 26. So we're going to get 39 point what? 6. So angle B is approximately equal to 39.6. 39, I can write 0.6 degrees. Throw that in your picture. What's left? Angle A, right? So what do I do for that? Yep. So measure of angle A is equal to 180 minus the sum of those two, 113.0 degrees plus 39.6 degrees. So the measure of angle A is equal to 27.4 degrees. So I'm going to throw that in here, 27.4 degrees. And then we're going to look at our side lengths and our angles to verify that our answers are reasonable. Across from my largest side, is that the biggest angle? Okay. Across from my smallest side, is that the smallest angle? Yes. And so it seems that our answers are reasonable. Now, I happen to use here the law of cosines to find my cosine of my angle B. Did I come out with the same answer? Using the law of cosines versus law of sines? Here I did, right? So I ended up with all of the same answers. Here's my triangle for that one as well. So I got the same answers for both of those, correct? Well, we're going to compare it on another example and see if using the law of sines still gives us the same answer. All right, so look at example 2. This time, you are given two sides and an angle. Am I given side B? No. So I cannot use the law of sines because I do not have the angle across from the side that I need it from. So again, you're going to use the law of cosines.
So what is that?
21, this is 75 degrees, 21 minutes. If you have double, you did that at the beginning of the year, darling.
Yeah.
Well, I'll show you how to find out in your calculator again. If we had double,
Yeah,
double apostrophes, right? Quote marks. Quote marks are seconds. You have to put in your calculator just like that.
So you do the entire problem.
Yep.
And then attach to it.
Correct. Yeah, it's a bit of a pain. So we're going to use law of cosines. I'm going to draw my triangle. Again, we're using A, B, and C. Across from angle A equals 6.2. Across from angle C equals 9.5. And angle B, 75 degrees, 21 minutes. So because I do not have the side opposite my angle, that's why we are using law of cosines. So we're going to start off with that. So law of cosines, I'm starting with angle B, so I want side B on one side by itself. Now, since I am solving for a side length, our solution is going to be slightly different than the one that we did above, because the one that we did above, we were actually finding the degree of that angle. So B squared, the other two sides are A squared and C squared, so they get multiplied or squared and added together. Then minus 2 times those two same sides, AC, times the cosine of what's on the other side by itself, which would be angle B. So plug in what you know. So A is 6.2, C is 9.5, and then my degree measure is 75 degrees, 75, I'm having issues writing today, degrees and 21 minutes. So I actually can throw this entire thing in my calculator exactly as you see it. And so that's what we're going to do. All right, so I'm going to take 6.2, square it, plus 9.5, square it, minus 2 times 6.2 times 9.5 times the cosine. Are you ready? So put in 75 first. Then if we want degrees, the degrees are in your angle menu. To get to that, you have to hit second apps. Do you see the degrees? So hit 1, or in this case, enter. So now I have degrees, and then 21 minutes is also in the angle app. Oops, there's a glare on there, and so we want 2, and then close your parentheses. Is everybody okay with that? If you happen to have seconds, which you don't, but if you had seconds, isn't the seconds above your negative key? And you have to hit the alpha, the green alpha key in my case. I think on some of yours it's white or gray or something like that. All right, so then I can hit enter. What did I actually solve for? B squared. So this is B squared equals, and I'm not rounding in my calculator because your calculator, the graphing calculators have a lovely handy feature. I'm going to round on my paper. Do not round in the middle of your calculation. I'll show you how you can get that answer without retyping it. So you got 98.8967. And I'm going to put a dot, dot, dot to show that it's a longer decimal than that. But how do I solve for B? Well, but how do I solve for B on paper? Square root of both sides, right? So I need to take the square root of that. So B is approximately equal to I want to get my answer in there, but I also have to start with my square root. So second function x squared gets you your square root. And then if you want that answer directly above there, go to second function, and above your negative sign says answer in blue. Hit that, and immediately puts that answer previously up there, and then hit enter, and it took the square root of that whole big decimal. If you round in the middle of your calculation, you get rounding errors. Rachel, you okay? So now I can round to one decimal place. So isn't it 9.9? So B is approximately equal to 9.9 units because I don't know what the units of measure are. So I'm going to put that on my picture, 9.9 units. B equals. So there's 1. Now, don't I have an angle across from my side? The problem with this is I really don't want to be taking the law of sines with my biggest angle first. So which side is the biggest? So that is my biggest side. So isn't this my biggest angle? Okay. So I feel safe using the law of sines. Now I'm going to tell you on this one, I believe the law of sines is going to give us a different answer than if I use the law of cosines, and we'll talk about that difference. So step 2, now that I have a side opposite my angle, let's find our next biggest side. Wouldn't that be C? Or my next biggest angle would be C. So since I'm finding an angle, I want my sine of my angle up top. So we're going to use law of sines. Yes?
On the test, if we use law of sines or law of cosines, we do know the 2 answers.
If I can follow your work, I will accept it. But if I can't tell what you did, I won't. So make sure that you're showing everything. Yes? It'd be nice. It'd be real nice. Yeah. All right, so I've got sine of C. And most of you have decent work, but some of you skip things. And or like this requires a lot of work. Your just work is everywhere. And I can't follow, you did this first, this, then, So you notice I'm doing step 1, step 2. That would be really helpful to the teacher grading your test. All right, so sine of C over side C. And then sine of B, that whole ugly 75 degrees, 21 minutes, over side B, which is 9.9. Now I imagine that C is going to be pretty close to 75 degrees because its side length is pretty close to 9.9. So if I want to solve for sine of C, I'm going to multiply this side by 9.5 and this side by, squeeze it in here, 9.5, right? And I'm really wanting to solve for C, right, not sine of C. So the measure of angle C is really equal to the inverse sine of 9.5 times the sine, I'm going to squeeze it in here underneath, 75 degrees, 21 minutes, all divided by 9.9. So I'm going to throw that in my calc. So inverse sine, 9.5 times sine, 75, second apse, hit degrees, 21, second apse, hit 2 for minutes. Make sure you close those parentheses. Then divide it by 9.9 and close that. So the measure of angle C is approximately equal to 68 point what? 68.2 degrees. Ah, there's no seconds. How do you convert? So if they gave it to you in degrees and seconds, shouldn't we have it in degrees and seconds? Okay, so go back to your apps or your angle menu. So go to second apps. See the DMS, number 4? That's degrees to minutes and seconds. So you're going to hit number 4, but then you have to hit enter. So you're going to ignore the seconds, and you're just doing degrees and minutes. So isn't it 68 degrees, 11 minutes? Right? So that's what I want to put in my my picture. So for C, I have 68 degrees and 11 minutes. Now what's left? How do we find that? Yep, sum angle theorem. So the measure of angle A is equal to 180 minus, add your degrees a minute, 75 degrees, 21 minutes, plus 68 degrees, 11 minutes. So the measure of angle A is equal to, throw that into your calculator, Mm-hmm. What's wrong with that answer? So it's not in degree minutes, so convert it. And we've got 36 degrees, 28 minutes.
Where's that mean minutes in minutes? Why minutes?
Because angles are it's not really time. So we can take our degrees and split them into smaller units, which are based upon minutes and seconds, 60 seconds in an hour. So 60 minutes in 1 degree. 60 seconds in 1 minute. All right, now let me show you what happens though if you had chosen in step 2 to do law of cosines. Oh, let me put this in my picture. 36 degrees and 28 minutes. No, you're just gonna evaluate. So if I had done law of cosines for my second step, do I have a difference in my answer? I do. So I need to warn you, really neither one is right or wrong. It's all really a rounding issue, and it's just a slight rounding issue. But you need to know I'm only a degree off, right? But since I'm a degree off here, where else am I going to be less than a degree off? My A's are going to be off as well. So my A on this one is 46 minutes, not 28 minutes. So when you go and you look at your answer in the back of the book, and you have these answers, but maybe the book has the other answers, you need to realize that it's a possibility that that's why you're off. If you're off more than a degree by a lot, then you probably did something wrong. Okay? All right, so flip. We got one more area formula to do. Here. They should be. If we're not within a degree, we'll talk about it, but they should be. I'm not usually off by more than a degree if we do that. But again, don't round in the middle of your calculations either, because if you round in the middle of your calculations and then you do law of sines versus law of cosines, now you're expounding that rounding error. All right, so Heron's area formula is used when you have only 3 sides and no angles to your triangle. Now we could use 1/2 base times height, but we'd have to find the height of a triangle that we haven't been given. So rather than have to go through the horror of finding the height, which we could, but it's kind of a pain, Heron came up with his formula, which, thank you, Mr. Heron. All right, so we have this formula right there. You'll notice that within the formula, it's got S, 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 and S. It's got S 4 times. There's your S. To find the value of S, you're going to add up all the sides and divide by 2. So we are not averaging the sides, we're just adding up all the sides and dividing by 2. So I'm going to go ahead and draw my triangle, bless you. And again, I don't know what kind of triangle I have, obtuse or acute, it really doesn't matter. But I've got A, B, and C. Across from angle A would be side A equals 43 meters. Across from angle B would be side B, 53 meters. And across from angle C would be side C, 72 meters. So the first thing that I have to find is S. So I'm going to take my side lengths, which are 43 meters plus 53 meters plus 72 meters. If I add meters together, don't I just have meters? Whoops, 53. So we end up with S equaling a nice 84. It will not always be a nice, little happy answer. Depends on what your side lengths are. So S in this case is exactly equal to 84 meters. We added meters together, we got meters, divided by 2, we still get meters. Now we're going to sub that into Heron's formula. Area equals, don't drop off that square root. So we get 84 meters times, I'm going to always take S first, so I've got 84 meters, so I want that in blue, 84 meters, minus each of your side lengths, 43 meters, times 84 meters, minus 53 meters, times 84 meters, minus 72 meters. And the nice thing about this is I can put the whole thing into my calculator exactly as you see it. But use your parentheses. And so I have an area that is approximately equal to 1,131 point what? 8 or 9? 9 what? It actually is meters squared because here we have meters. This will give you meters, that's meters squared, times meters again, meters cubed, times meters again, meters to the fourth. What is the square root of meters to the fourth? Meters squared. Questions? Are we good with that? Yes. No. But don't forget to put in your units of measure. Area is always squared units. I'm just proving to you why.